Sorry about that. My stuff just froze and it didn't let me hook up my camera again. I don't really know what to do when that happens. So I'm just texting Dylan back. We're gonna try to get this all sorted again. What's up? I don't know. I mean, you can't. I do theory. Okay, you can't expect me to know how to work with anything for real. Are you kidding me? Let's go ahead and we're gonna try to get Dylan back here. Yeah, it lets you. So this little software that I'm using lets you hook up your camera, but then if your camera craps out, then it doesn't give you the option to try again. It's just like, well, that's the stream now. Cool. So I guess by the rules of YouTube, Dylan now owns my channel. Let's try to see. I'm not sure if the invite link that I have to send him is the same. Let's go ahead and try to get him back. Oh, this is the first time I've ever done a live stream in my life. Can you tell? Can you tell that? I'm going to send him this link, get him back here, and then we'll get all interactive. What do we got here? Hey, you're back. Yeah, I'm back. Okay, so it looks like Dylan's back as well. He's coming back in 3, 2, now, hopefully.
Shit. Oh, shit. Okay. How we doing?
Okay.
Ladies and germs.
Fingers crossed that doesn't happen again. I was letting the chat know that I saw that it froze me. So I exited out of myself. And then that little webcam icon that it says, okay, would you like to hook up a camera? It wouldn't let me do that again.
Oh, hell.
So I was just trying to figure out how to do that. And I was letting the chat know that now I guess you're a proud owner of my channel by the rules of live streaming.
You know, I've got to say, I don't think I did the worst job ever. I just think I did a moderate. I think I did a moderately subpar job. Oh, I got to turn my camera back on. Don't worry. Don't worry.
It's all right. It's all right. You're good. All right, let's start reading through some of these comments. Again, I don't know how to make it so that the comments don't stop just updating by themselves. Do you know how to do that?
I think there's this thing called like slow mode or something that you can. I think the best thing to do would be go to your actual live stream. Or so I don't know if we can do it right now, but I think you can say, Dylan has Wi-Fi, but Andrew is on dial-up. No, fuck no, dude. I'm on Ethernet. I don't even want to hear it, RC. Anyways, it's called slow mode, and I saw actually Kyle Hill do it, and I haven't spoken to him in like a week. I would have asked him if I knew that, channel this would happen.
This is going to be a bit of a work in progress. Sorry if people expected this to be, without any bumps, but I've never done this before. So, and I do have Wi-Fi. It's just I'm connected to United Airlines Wi-Fi, but they're flying over Chicago right now, so the connection's a little choppy.
There's nothing better than Wi-Fi based on dial-up.
Is dial-up still around?
No, and I don't think.
Or is that just a fleeting memory for all of us?
Actually, I think they just gave it a different name. I think they call it broadband now.
Oh, it's like what Internet Explorer did with that whole Microsoft Edge.
Exactly.
We know what you are.
Yeah, we know who you are, and we don't like
just own it.
Yeah, just be like, yeah, dial-up stuff, whatever. What? Why does everybody think I'm drunk? Come on, this was not.
Yeah, guys, give us 15 minutes and we will be. We swear.
Yeah, I mean,
Physics, one of the OGs of the channel. I will find you. It's always cool seeing people who are have been commenting. Oh, and Doc Alex as well, who have been commenting for a really long time. Just the loyalty.
Yeah, there's supposed to be some kind of algorithm that prevents them from spamming the chat, but there's just so many.
How many people are in right now? Do we see? Oh, 219.
That's way more than any of my live podcasts has ever gotten. Like at an instant.
Did you start live streaming on Twitter? Does Twitter do that? Dude, I'm so out of time.
No, Twitter does do that. But nobody really watches it. Nobody puts together segments, on it. Like it's just not good.
Just want to give a quick shout out to my buddy Cully. I think he just saw that the live stream is going on. Cully's the guy. Sorry to interrupt, by the way. Cully's the guy who got me like convinced me to actually make a YouTube channel. It's one of my best buds. Okay, slow mode. Ali, I'm trying. Well, actually, no, I kind of gave up on trying, but I'll try again. Let's see if we can get this chat slowed down a little bit. I was in. Did you tune into?
How about this?
What's
Sorry. I can, so you can be the, and I can parse through these basically. So I've had some people ask you to do USub and trig sub, both of them. Do you still know how to do a USub, or not USub, but a trig sub
USub
integral?
for sure. Absolutely, and I can do. I can do a lot of the. So here's the thing with the trig sub. I remember what the integrals are, and I remember that you use trig sub to do them. Like the integral of 1 over x squared plus 1. Like I know that that's arctangent just because I had to do it once. But
so you know it's x equals tan theta is the substitution.
Yeah, that's right.
It is,
but
yeah.
It would take me a minute to draw the triangle and be like, why is that this next this?
Yeah.
You know what I mean?
Yeah, no,
but
I'm with you.
USub for sure. I don't think anyone should forget USub.
Yeah, no, USub is just, yeah, no, don't, if you ever forget USub, just don't do that.
Someone says, I usually watch videos at twice speed, and y'all are talking so slow right now.
Wow.
You should. I feel bad whenever I speak with Kelly, my girlfriend. She'll ask for an opinion on something, and I'll just pause. I'll pause for a minute. No words. I'm just thinking of what I want to say.
That freaks some people
on the other
out.
side of things. That's got to be weird.
Yeah, it's like, so what do you think?
I'm just trying to figure out. I'm taking a minute. I'm in no rush. I'm sorry that we're not getting to people's comments, but I'm trying to make it so that we can. Because
so we're asking for a bit of self-policing, I think.
And I'm also.
Go ahead. Yeah, sorry.
I'm just going to try. I'm over to my YouTube studio right now. I'm seeing if I can access any of the
YouTube
properties of the live stream that I can change ad hoc.
And so does anybody, so while he's doing that, does anybody have, since this is QFT and Chill, does anybody have any quantum field theory questions, which I actually had a very insightful podcast on, Physics After Hours on my YouTube channel. You might want to check it out. You might not. Okay, that's the last plug, I promise. Okay, Yo Mama 09. Okay, Yo Mama 09, it's no longer cool to ask who I am. But I guess I should introduce myself. My name is Dylan Berger. I am mostly known for my Twitter. I am at Inertial Observer without the second E in observer and the third E overall. If you want to follow me, that'd be cool. I like to make animations, but lately my passion project has been
whoops.
Dylan's
I'm figuring
joke.
this out. I'm sorry.
Why'd you got all the things you had to do is that one? But yeah, so that's kind of what I'm doing. And my passion project lately has been the podcast, Physics After Hours. This is kind of something I've really, really enjoyed talking to people. And okay, so I see a bunch of people saying, "Show my boy Feynman some QED love." I don't know how to do that, but okay, yeah, quantum electrodynamics is a beautiful. Yes, that's a good question. I am currently a PhD student in theoretical particle physics at University of California, Irvine. So yes, I am getting my PhD. I'm not just some dude who reads Wikipedia articles, but nothing. If you're out there and you read Wikipedia articles, then keep doing that. So
someone asks, is QFT just residue theorem and renormalization? I like that.
No, that's like saying, is physics, classical physics, just calculus? But I would definitely say no. But I mean, renormalization was never baked in, and that's one of the remarkable things, is that it was never baked in to the theory of quantum field theory. Renormalization emerged from this idea that we were forced to do a perturbation expansion, and finding that this coupling constant gets large as we vary the energy scale. And it's a really, really remarkable thing. Like I said, it's really, really great. So again, okay, I just introduced myself. I don't know how these comments are lagging, but yeah, I'm a PhD student in theoretical particle physics at the University of California, Irvine, and Andrew's my homie.
Well, reintroduce you every like 15 minutes or so just to be safe. I'm sure it's like a rolling audience where there's 426 people right now, but I bet, people are popping in and out like particles all the time.
Yeah.
Okay.
So I saw 2 questions there. Sorry, go ahead. Yeah.
Oh, go ahead. You got some questions? I was just going to say, let's read some.
Yeah, I saw 2 of them. There was one of them is the difference between QED and QFT, and then the other one right under that is topology ever used in QFT?
So I'll take the first one. So quantum electrodynamics, QED, was the first quantum field theory. It's the quantum field theory. You quantize the electron and the photon field. So the fundamental objects of interest in a quantum field theory are the fields themselves, and then the excitations we interpret as particles. And what's interesting about quantum electrodynamics is it is it's the prototype, it's the template that you use for developing other quantum field theories. For example, for QCD, quantum chromodynamics, you do the same thing. We say, oh, wow, imposing some sort of local gauge invariance and a Lorentz invariant Lagrangian seems to get us actual observables. Let's use that. You define the interactions in much the same way in terms of the field strength tensors. But the only difference between QCD and QED is when you define these field strength tensors, you get extra terms for QED, or for QCD, sorry. So QED is a quantum field theory. It's the first one. All other ones, more or less, I'm sure there might be some exceptions, were based off of QED.
Yeah, no, actually, that is much more pedagogically nice that you put it that way. The idea, I guess, me being kind of enveloped in this theoretical world is that I guess I would say that QED, right? So it's the theory of electromagnetism, most fundamental way, which you did say, and then you said it was the first one, which was true also. I feel like I'm about to see, but that was a lie. You're like Maury or whatever.
Oh, it wasn't?
No, it wasn't a lie. It was you saying like they were all kind of based on QED. I'm sorry. Yeah.
At least QCD was, for sure.
Yeah, no, they all follow the same pattern. And you were exactly right, was that you have to write down a Lorentz invariant Lagrangian. Everything else, all the laws of physics have to be the same in every inertial reference frame. And you say that you need to gauge a symmetry. It's just that the SU3 symmetry is, like you said,
that's a good point.
Yeah, you get these you get these extra interaction terms, but the thing that drives that home is that the generators of that symmetry do not commute. And so for those of you in quantum mechanics, commutation relations, that's exactly what it is that the generators of those symmetries, AB doesn't equal BA. And then when that happens, right, when you do the commutator, if A times B is not the same thing as B times A, you get a fudge factor, and that fudge factor is the interaction between the gauge bosons, the gluons, but you don't have a self-interacting photon, right? You don't have that term because they do commute. Their generators do. So it's very, very cool.
Have you ever had to calculate the Feynman diagram? So yeah, in QED, photons
Feynman
don't
diagram?
directly...
Me? No.
Have you ever had to do that before? So there's the diagram where, photons don't directly interact with other photons because, at least from a field theoretic standpoint, it's because there's no structure constants, or it's zero, I guess you would say.
Right. There's no tree-level interaction.
The field strength tensor. But they do interact.
Yeah. Photon scattering. Yeah, exactly.
Yeah, exactly.
It's a beautiful.
I haven't had to calculate that diagram explicitly, but that was kind of cool when I first came across that photons can interact with each other, sort of.
Yeah, no, that is an amazing thing. And that's another beautiful thing about quantum field theory is that what you write down in your Lagrangian, this process of renormalization and loop diagrams and dealing with these infinite terms and imposing cutoffs will tell you things that actually can happen that your original symmetries forbid. And that is an amazing fact of quantum field theory that, again, wasn't baked in, but it happened. And it's true.
So I'm seeing a few comments about, like, what the hell are we talking about? Maybe we should...
yeah, sure.
Maybe we should take it down to... We take it down, then build it back up. Make sure everyone's on the same page. So I think the first thing was, why do we need quantum field theory?
What was that? Was that Austin Powers? Mini-me. Turn it down a bit.
Yeah, and that's a movie I haven't seen since 2007 probably.
Yeah, me too. Okay, so sorry, go ahead.
So, do you want to talk a little bit about what quantum field theory is? Maybe not to
Yeah.
put you on the spot.
Well, I mean, I think about it like I said, like I just talked to this guy David Freeborn last night on my podcast about like very very sophisticated issues. So I'm still kind of in that mode, but let's see if I just say it's the fundamental theory that we have. It's so if you've ever heard of the standard model of particle physics, you got your bosons, you got your photons, right? You got your W and Z bosons, and then you got your gluons, and those are the force carriers, right? They're bosons. And then you got your fermions. You got your quarks, your leptons, your electron, things like that. And then you have, which one am I forgetting, Andrew?
You said bosons and fermions?
Right, yeah,
Boron.
no, I did say bosons and fermions, but I guess I should have said gauge bosons and fermions. I just listed them off. I forgot the Higgs.
Okay.
Yeah, no, I'm sorry. I didn't mean to put you on the spot there.
Sorry, I
But
was
yeah.
reading the comments a little bit.
He's like, I was just, yeah. But yeah, so you got these, and those are all, we think of things intuitively as particles, but actually they're not. That's not the right way to think of things. The right way to think of things is fields. And as a shorthand, you can think of particles as excitations of fields, but it's really, really not that clear looking at the math. There's a lot of fundamental questions about, this and that. But I mean, I'm okay for the context of this conversation saying it's, a particle is an excitation of one of these fields. And a quantum field theory says, I haven't said anything quantum yet, is when you take those fields, you write down, just a Lagrangian that gives you that obeys certain symmetries, but you also further impose the quantum commutation relations, right? The commutator of position with momentum is IH bar. You do that same thing, but you do that with fields, and it's a very very difficult thing. And I mean, if I'm being honest, we don't understand entirely how it works. At the most fundamental level, but it's essentially the same thing as quantum mechanics, where fields are your degrees of freedom instead of particles.
Yeah, that's a good way of putting it. So another thing is, for those of you who've had any quantum mechanics, you've been introduced for the first time the concept of an operator.
Mhm.
And in a lot of cases, these operators, we think of them as matrices, some case continuous matrices. And when it comes to quantum field theory, so quantum observables are replaced with differential operators. They're linear operations acting on some vector that lives in a Hilbert space. In a quantum field theory, there's two primary approaches. You can either take it even one step further, where now instead of just the wave function, some vector, the thing of interest, the wave function itself is promoted to an operator.
Exactly. Yeah.
So in that, there's different ways of doing that. As Dylan mentioned, there's the canonical quantization approach where you define the commutators. And so in that way, it's like you're making the actual fields themselves become operators. But then you have people like the boy Feynman that went the complete opposite way. And this is why I love Feynman. I mean, I just thought it was awesome because you spend a year or however long learning quantum mechanics and becoming comfortable with this operator formalism, and then Feynman comes along and he says, "Let me. Here's our time evolution operator, initial final state, and let's just see what happens. Let's insert completeness a billion times, and wow, there's no more operators anymore. Now we have this new thing called a path integral." That's
an amazing fact.
Field theory,
and you mentioned that on my podcast where you said, and it's a very very true fact and a beautiful fact is that, and I think what you were alluding to there is that even though quantum field theory is one of the most quantum of quantum things you can get, when you use the path integral approach, you don't really need to talk about operators because you write about classical action, which is remarkable. It is such a remarkable fact. No more operators, no more any of this. And it's the integrating over all paths where you get that quantum nature. It's just so
One of my
cool.
favorite things about that is the two different thought process you can have when you do that. So when you have the path integral, you have this integral over all the field configurations, and then you have this exponential of the action, or I times the action.
Mm-hmm.
And you say, how the hell do I do this integral? There's two ways you can think about it. One, I mean, e to the I something is oscillatory.
Mm-hmm.
And the action, you have this notion of energy being associated with it. You say, oh, all those very highly energetic oscillations, those average out to zero. And the only ones that contribute to the probability amplitude, to think like what the particle is actually doing, are the ones that minimize the action. And the same thing goes. The way that I like it, I don't like that one as much, to be honest. What I like is the whole go to Euclidean time. So you go to imaginary time.
I love that
in
too.
which case e to the I action becomes e to the minus action.
Yeah.
And then instead of having these wild oscillations that you have to argue away, you just get a function that's critically damped. So the higher energy paths wouldn't contribute in the first place. I love that.
Right. But then, you're faced with this, instead of, dealing with these oscillations, you have an ontological question to answer of, well, what does it mean physically to actually go to imaginary time? Like, what is it? Just a convenient mathematical trick, or is it?
Absolutely, that's what it is.
Oh,
that's the
it
concept
is.
of it's analytic continuation. You say, I can't solve this problem here, but let me go to a different problem that encompasses that problem and more, and solve it there, and then transform back. Right? That's what you do. So
yeah, no, I mean, it is a convenient math, like you were saying, absolutely. But I didn't know, and I think it's a very, very interesting question to say: is it just an interesting mathematical trick, or is there something deeper? Like when Planck, fit the blackbody radiation curve by representing it as a geometric series in exponentials with quantized h bar omegas. That you could have just said that was something that he just used as a fitting tool, but
right.
but it does actually mean something, said Einstein, and of course said Einstein, so it was right.
There's a freedom that we have, though, to choose a metric signature, right? You can be you can be what we are, which are the plus, minus, minus, minus boys. You can be the gravity people, like Kelly and Farhan out there, and do the minus, plus, plus, plus. But then there's also the people who are like 150 years old that probably use that imaginary time, that Euclidean time metric. Some people, I think there's Jackson. There might even be Jackson editions that employ that.
I see what you're saying. So you're saying that it's, but I don't. I see what you're saying, and it seems like what you're saying is that like this imaginary time formalism of special relativity, right? Or I guess what you're saying is that this Wick rotation going to imaginary time in quantum field theory is just as arbitrary as choosing a sign of the metric, right?
That's my first thought. Yeah.
No, I agree, and like that is very tempting because it seems like that's what would be true. But when we actually Wick rotate, we don't then change the metric. We leave the metric fixed.
Oh yeah, that's true.
Exactly. And so it's like it's not like switching conventions will all of a sudden make my integral converge, and then it's a but it's a really
I have to think about it more then. So let's go through some of these comments, because I don't want this to just be a dialogue between the two of us. I think everyone could use a bit of interactivity right now. So we've got Onur. Oh, that just sounds like he's answering someone else's questions. I hopped out. Tyler says, I hopped on to take a break from studying. Now they got me hyped.
Yes, that's good though, right?
And then someone says, Micah Church says, so analytic continuation is like how in defining a uniform continuous thing where you just get a superset of the thing you're dealing with. That's sort of what it sounds like to me. So you take a function that's also defined, like we're e to the x. I'm talking about reals, but if I make x complex, nothing weird. There's no undefinedness that comes along with doing that. So I'm just as able to solve the problem on the complex plane and then go back. So I think the way that you're thinking about it is correct. Another person, Cracker Cheese, says, Jesus, these comments are going too fast. I read about solving Maxwell's equations on knots. What other branches of physics uses knot theory? I wish my buddy Abhishek was here right now. He knows a bit about knot theory. I don't.
I do not know the answer to that question.
I know I've heard something about like...
You missed the pun, Andrew.
Mapping a problem to whether or not there's a knot. And then if you can unknot the knot, the problem can be solved.
Oh, that's
That was like that's my superficial surface level what I've heard about it.
So there's
Why is
one here from Court Beck who says, "Could you please explain SO3, SU2, please? Spin stuff, etc."
Yeah, I mean, one is just the what do they call it? The universal double covering group to the other.
Yeah, that's it. Moving on.
Yeah, idiot. No, I'm just kidding. So I actually do have a hard time with that at times. So when you talk about SO3, we think of that as the group that corresponds to rotations in three-dimensional space,
Right.
and SU2 is the group that I normally associate with spin stuff. I don't have. That's such an abstract question, and I
Yeah,
don't
it's a
know how to
difficult
answer it
question.
without abstractness. But if you talk about when you talk about a group in a group theory, you have, as Dylan mentioned, these generators. So when you talk about Lie groups, that's what these are Lie groups. You can write any element of the group. So the group is just defined by a set of axioms and criteria, and any element of that group should be able to be. You can get that from the exponential of a sum over these generators. I can get if I know what the generators are, I can generate any element of that group from them. And you can represent these groups in different ways. Okay, there's fundamental representation. So when I say SO3, people automatically go to that's the group of all 3x3 orthogonal matrices. That's one representation of the group. That's the fundamental. But we can look at it in different ways. And if you look at it in a different way, the form of the generators may look different. Okay, so what you get for SO3 versus SU2 is that the generators of SU2 in one representation will be the same as the generators of SO3 in their different representation. That's the best way that I understand them. And that was kind of good enough for me. I don't know if you can share some insight onto how you think about those things.
I mean, I'm not going to rant here. I mean, you said everything correctly there in terms of how the algebras work. And yeah, he's like these when he said same, they satisfy the same relation, and I don't have any intuition behind why spin adds the way it does. Okay, so here's a fun one though. Moving on to Cracker Cheese, he says, Dylan, what did you think about Jackson classical electrodynamics? Oh, I got one too. Where is it? Oh, it's I guess I burned it. Sorry. So yeah, no, I actually liked it. I thought it was good, and I'm not saying that to try and sound smart. I'm not saying it was easy. Like the problems were easy. I thought they were, very difficult. But I think still to this day, my greatest academic achievement is finding an error in one of the Jackson editions.
Oh, really?
And I lost my mind for a week. I thought I was so wrong, and like
You remember
because
what
he said.
section?
It's on my old website I had. It's problem 3.1c, and part C, and it was showing that this integral converged to a certain number, and if you have the addition, if it is if it's a if in 3.1c it's an infinite sum, that's the correct answer. But I rented the book from the library originally, and it said show that it's equal to secant or something. And I was like, that is so beautiful. That is fascinating. And so I worked it out, and I dug and this is when I was an undergrad. And like I was like in a graduate course, and like I was like losing my mind. And I found this integral actually is secant, but it comes from a misapplication of this identity. And I was like, well, you can't. It essentially just it proves it for all integers, but not half integers. And I'm not going to go any further.
Man, I mean, so I just looked up what section that's on. So that's boundary value problem stuff. So that's like when you start going into Green's function stuff, I think, right?
Yeah, exactly.
Man, that was speaking of Jackson, that was probably I mean, I knew about Green's functions because we do field theory stuff. We talk about propagators, right? But like one of the most annoying things about Jackson, which has anything to do with the fact that it's Jackson, but it just has to do with how they approach Green's functions, is like you either say, wow, there's a symmetry in this problem that looks like the problem that I've already solved, like you use method of images, and you kind of just guess the Green's function.
Right.
right? That's one where
Mhm.
you just, and I was like, what if, what?
Yeah,
Why,
no,
why didn't you just do that? I hated that.
yeah, no,
I was gonna say,
that's true. He doesn't explain Green's functions. He expects you to learn it in an undergrad course, which, of course, in which they told us we would be expected to learn that in a graduate course.
yeah. I yeah, I had a good. My professor was really good. I learned about Green's functions and math methods. That was my first exposure in
Yeah.
grad school. So, my
Oh, nice.
professor,
Yeah.
yeah, he took this whole like, yeah, you have a matrix acting on a vector, giving you another vector,
Mhm.
and say you want to find the first vector. Well, you can invert the matrix. And the same thing, if you have an
Exactly.
operator acting on a function, giving you another function, does it make sense to ask about inverting the operator? And then that gets
Mhm.
you in a roundabout way to learning about Green's functions. I thought that was great.
Exactly.
I'm
And for
finishing
you
up
kids out
Jackson
there
E&M now.
Oh, nice. Um, and for you kids out there, operationally, it is if you have a differential equation with a source function f of x, the Green's function is just the solution of that differential equation where you replace f of
Mhm.
x with a delta function.
Delta function, yeah. Yeah, it's a cool way of saying I have what if I have a delta function source, I can generate any arbitrary source as a linear
Yeah.
combination of those where we express it as the Green's function. I thought
That's a
about this stuff
beautiful
for
way.
so
It's
long.
amazing. It's amazing.
Uh, I saw one from. I'm sorry. I'm trying to. I'm going to play a little bit of
Mhm.
favoritism just from the people that I know have been commenting and been active for a long time. So
Yeah.
whenever they comment, I want to make sure that I
Mhm.
get to that if I see it. Uh, so do you know anything about metamaterials? I'm not sure about that.
I think metamaterials are just like I think that's a term you use to mean like exotic, just like kind of materials that exhibit these kind of exotic properties.
Like Majorana fermion stuff or
Yeah,
topological insulators, weird
exactly.
stuff
Yeah,
like
yeah,
that.
exactly. Stuff on that level, and I don't know anything about it beyond that.
Me neither. I know buzzwords. Uh, does the chat go up or down? Am I reading the first comments? Oh
No,
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 it's
yeah,
just a
yeah,
couple
yeah,
times.
yeah.
Okay. Um, let's
So
see.
this guy's asked this a bunch of different times. What's the difference between diffraction and interference?
What's kind of cool, this isn't going to answer the question, but when you learn about scattering versus diffraction in like Jackson E&M, they're the same problem, but just with different geometries.
Mm-hmm.
But diffraction and interference, I think Feynman's actually kind of answered that question where he says, I think we
Mm-hmm.
use them
We did
interchangeably, but if you have more than one source or something, they may
exactly,
use one or the
exactly,
other.
exactly. That's always where I go back to. Is that I mean, it
Yeah.
seems like we use them to mean the same, but interference, is a well thing. Diffraction, I think we just like use it in the context of light.
Yeah. If someone's like if someone says diffraction, I'm not gonna be like, wait,
Yeah.
do you mean interference?
Yeah,
Yeah,
exactly.
I
Don't
can't
use the
distinguish
frac.
the two.
Moral of the story.
Marin says, what are your views in chemistry? I love chemistry. If I didn't do physics, I don't think I would do math instead. I would probably have done chemistry.
Interesting. Fascinating.
Yeah. Chemistry was a cool class. I took organic chemistry as an elective in undergrad.
You fucking nerd.
And when I say that, I'm like, I say that people form an opinion, like they feel some type of way. And I'm like, wait, no, I didn't know that it was an elective at first. Because initially I was pre med. So I had to take organic chemistry. And then I
Yeah.
changed to physics. And they were like, well, now it's an elective for you. So it inadvertently became an elective.
Right.
And it says, my internet is dying. Goodbye, guys. Goodbye. Thanks for tuning in.
Thank you, Anna.
Abigail says, Griffiths, E&M, or Jackson? Griffiths
Ooh.
it's
Yeah.
incredible,
Yeah. I
but
mean,
it
Griffiths
only will
is.
take you so far. You'll outgrow it.
Yeah. But if I was stranded on an island, and
You
like,
had to rederive electricity.
yeah, no, I think I have a lot of kind of Griffiths in my bones by now, but
Hmm.
that's the thing is that I don't know if it could be as in my bones if it weren't for Griffiths. So,
Right.
um, it's a tough one.
You
But
don't
we all
learn. You
sacrifice.
don't learn E&M. with Jackson. Jackson, like page 1 is recall Maxwell's equations, right? It's not an
That's true.
introductory book. Like it
Yeah.
assumes you already know some E&M.
Mhm.
Just like how Pathria statistical mechanics, it assumes you know thermodynamics,
Exactly.
which is
yeah.
fine. I mean,
Yeah. Thermos. Yeah, it's fine. PV equals nRT. Wow, mind blown.
okay, let's keep going through some of these comments. Why do space and time have opposite
Ooh,
sides in the
that's a good
Minkowski metric?
question. Because space isn't equal to time. It's that simple. I mean, like
Yeah.
that is the distinguish. If you don't have that minus sign, right? Then I mean,
You have distances.
exactly. Griffiths actually says this the best in his electromagnetism book, and it's
Oh,
like
really?
I think it's a footnote in the special relativity section, and because he's talking about because when people talk about relativity, they talk about treating space and time on equal footing. That is, in a nutshell, kind of what relativity is that space is not more important than time. But they are different things.
Right.
And relativity, right? That relative minus sign is the embodiment of that difference.
That's a good point, because when you hear it thrown around that especially in things like natural units or something where time and space have the same units,
Right.
it's easy to say, oh, they literally are the same thing. No, what it's
Mhm.
saying is when you have a really relativistic equation, if you swap position with time, the equation shouldn't change. Like if you have the wave equation, if x goes to t and t goes to x, like you have those 1/c's that also switch and stuff, the wave equation doesn't change, right? So you say time and space are on equal footing. They both have these second derivatives and stuff. But as Dylan's saying, yeah, they are different things. When you go to Euclidean space, again, I don't know how to. But well, then there's an I, right? So
Yeah,
then
exactly.
It's still different because there's the metric still has an I in there. So okay.
Exactly. It's a beautiful thing to think about. That's for sure.
Okay. That's a sexy whiteboard, Andrew. Thanks. I get a lot of comments asking what it is. It's a quartet whiteboard. I think it's 6 foot by 4 feet, maybe.
They should pay you for this is free advertising for them in front of like 500 people.
Yeah, I know your grandpa told you to never advertise something for free. That's what it was, right?
Right, yeah.
We
Never
got
advertise it for free.
Not yet?
Just looking.
They're just looking?
I was just
Okay.
seeing, got that nice bottle over there. Yeah.
Do you want some Jameson?
No.
Well,
You
I
have
have
some.
some tequila if she wants to have some
Yeah,
of
I'll
my
take some
tequila.
tequila.
Kelly says she'll take some tequila.
Oh, hell yeah. She's a keeper. She's
Cool.
a keeper, Andrew. She's a keeper.
Yeah, she is. What is the correct signature? Plus, minus, minus, minus. People are fixated. Maybe it's me hyping it up. It doesn't matter objectively, but if you use minus, plus, 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 you're wrong.
Yeah. It doesn't like you're still a human. Like if you do.
But less of one is quantum gravity, quantum field theory.
Sorry.
You know about this more than I do, for sure.
It's
I think you do, right? You do, like, you've looked into that a bit.
Oh yeah, for sure. It is. It's a non-renormalizable quantum field theory. When everybody so the idea is that it depends on what you mean by quantum gravity. What most people mean by quantum gravity, and this is a beautiful fact actually, is like as we were talking about before earlier, there seems to be this pattern. Is that if you have a symmetry in your theory, you gauge it, then you get force carriers, and that gives you all of the forces, and so it's natural to think what happens if you gauge the Lorentz symmetry, the relativistic symmetry of the standard model Lagrangian. What do you get? You get Newtonian gravity. And what is the gauge boson? You get something we would call a graviton. And if that's what you mean by quantum gravity, then absolutely, it's a gauge theory, it's a quantum field theory, and it. But it's also non-renormalizable. You run into a lot of issues, which is why people say quantum mechanics and GR, general relativity, have yet to, kind of merge in the right way, which is true.
So the non-renormalizability comes from the fact that big G has dimensions, right?
Exactly. That's precisely right. Yeah.
Yeah. So what I do, my primary area of research is trying to understand a very specific term known as the D term, when you calculate these cross sections, come on in. Never mind. We're gonna take a break on the heavy
All right.
physics thing first. In the chat, can we get some happy birthdays for Farhan?
Oh no!
It is.
Oh wow, Farhan.
So this is Kelly. This is Farhan.
No,
No,
you
this
did
is
it
Kelly.
backwards.
This is Farhan.
This is Kelly, this is Farhan.
And it is
Who knows who it's
Farhan. Well, it was Farhan's birthday, so we're
Okay.
drinking for him tonight. So
Yeah.
happy birthday, Farhan.
Wait, I brought you a shot. Happy birthday, Farhan!
This is just water, right?
Yes.
Yes.
Ready?
Let's do clear water.
Cheers.
What?
I'm sorry. You didn't even
Oh.
cheers me.
Cheers.
All right, yeah, I got to do this with you. All right, hold on. It's a good thing.
Chug,
Got
chug,
some happy
chug.
birthdays. Got a bunch of happy
Yay.
birthdays.
Farhan,
Why
what do you
does the
study?
photon have mass
It's a good,
Good question.
birthday question.
within its
Good
own
question.
reference frame? That's not a bad question.
Wait, Farhan, what do you study?
All right. I study astronomy.
Oh hell yeah, stars and shit, right?
So both of these
Stars and
Stars.
shit.
Yeah, basically.
No
stars
star.
et al.
We study
And,
galaxies.
Oh, yeah, that's the academic way of saying it.
Yeah, these are the minus plus 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 people.
Oh, you can leave.
Okay, bye.
I'm kidding. Come back. Oh no.
Daniel G says, "Stop making us feel lonely." Farhan is the goat. Alex,
Oh,
Yes.
Thank you. I've always wanted to do the
there are 472 people watching.
Right
Hi.
now, in this very moment. Oh God.
Yep.
I'm not
I
nervous.
think-
You're nervous.
But that I don't know.
Yeah, no, that number is probably true. Physics After Hours with Inertial Observer, Dylan Berger. Check it out on YouTube.
Yeah, you make this look easy. It's so easy to zone in on something else and then just not
Yeah.
talk for 2 minutes. And you're like, oh shit, I'm supposed to
Yeah.
interact.
and chill.
I'm gonna if I get like more subscribers, I'm gonna have to either get a producer or something, or a mod or something in the chat, because like it's
Mhm.
I mean, because
I know
this is difficult to deal with.
a lot of people have been talking about me making a Discord server, which I'm not opposed to, but I understand that moderating and things, I don't want.
I already have one that I kind of let go in the way for theorists. So I mean, but I could revamp it, and like, it kind of went up. So I could just like make you joint mod, and
You guys heading out?
Yeah, we're gonna go.
Feel free to come back and answer some questions and stuff with us.
Are we gonna solve problems? What are we solving?
Um,
Oh wait, does anybody have astronomy questions? I'm just curious.
Yeah,
oh yeah, let's
Astronomy.
go.
it might take a minute for people to type out. They're getting so.
Yeah, these are big
Nancy.
questions.
I know,
How do you-
man.
That's going
I don't.
Oh, hi from Reed. Oh my God, what?
Oh, yay!
Hi, Reed,
That's
you
your
represent.
piece.
Reed, I knew I could count on
Oh
you.
yeah,
Oh.
Right on.
Oh my yeah.
There's been a few
So
people who've been like, "Do you know
Talk about-
Farhan?"
Faraday's law. Let's talk about Farhan
What?
volumes.
yeah, Farhan.
Thank you, Mason. Okay, so join Flammable Maths Discord. That's not a. Yeah, that's a good idea.
No, join we could all just like kind of like merge. I don't know if you can do that on
Biggest
Discord.
star. That's an interesting question.
7. The answer is
Uh,
7.
Oh,
Stop.
hold on. I just want to make sure I know what this question is because it looks
Your star's
interesting.
fucking,
Oh,
yes.
heck,
Sorry, is this a Christian channel still?
this is a great.
I'm sorry.
I love her. What's inside a black hole? Do you know the answer to that?
That's a good question.
Ooh.
I think everyone can agree that's a good question.
Yeah, that's the answer.
Virtually, no one knows the
What is
answer.
inside? What is inside a black hole? A
What
lot of
you tell
people
me?
named. Wait, I know the answer. I know the answer. A lot of
Yeah.
people named Alice or Bob.
Yeah. That's funny.
For real?
Yes, Alice and Bob. Exactly.
If you're throwing Bob into it, though, it's like the epitome of that long goodbye, where it's like, all right, like if you're from the South,
Yo, you told me how long that was. Someone read the whole thing.
if you're from the
Yeah.
South, those family goodbyes where you're standing at the door
Unbelievable. Thank
threshold
you.
forever, just be like,
Great.
all right,
Yeah.
bye. Oh, by the way, how's Auntie May? Oh, she's doing good. She's doing good. Okay, yeah. Well, anyways, her grandchildren told me that Reed, that's the Bob thing where you never actually see him leave
I see.
forever.
I thought you were going at like this idea of like the fading Titanic lover, like into the ocean, like slow flute playing in the background.
So, Farhan.
Yeah.
Quick spiel. What are you researching?
Yeah.
And also
sorry
get
you
in
did
frame.
that, so you...
Okay, so I'm working on basically the evolution of galaxies across cosmic time, and the way
Evolution is just a theory. It is not fact. Evolution is a theory.
Yes, that's my research.
Why are there still monkeys?
Oh my God.
but you don't have to worry. This is not anti-biblical. Like it doesn't. This is evolution of the universe.
Yeah, it's in the Bible.
Can we make it anti-biblical?
But yeah, so I study.
Just kidding.
I work on how galaxies evolve, and the way to do that is to first realize that galaxies are like ecosystems, right? So they're basically like jungles or like forests or whatever ecosystems we have on Earth. It's like that, but imagine that on like the Milky Way scale, right? It's a huge ecosystem. There's stuff always coming into it, going out of it, right? And this is what determines like how they grow, how they evolve, how they influence the environment around them, and how they shape the universe. I'm studying a small portion of it. I'm studying how gas cycles into and out of galaxies, which I guess is not that small a portion of it. That's a pretty important question, but yeah, I'm studying how gas cycles in and out of galaxies, and because this is like you can imagine a galaxy as a city, right? And you can imagine a galaxy as a city, and you can imagine whatever is outside of the city as the whatever the halo.
Immigrants. I'm sorry, that was not PC.
But yeah, so like I study whatever's outside of the galaxy. It's like the suburb to a city.
So how the suburb affects the city.
Yeah, I'm studying how the suburb affects the city.
Well, what is the suburb in the context of your research, though, I guess?
The suburb, yeah, go on.
Yeah, it's like, what is... I'm getting lost in the analogy of what the suburb is, I guess.
Yeah, so the suburb is basically the halo of gas that's surrounding galaxies.
Oh, right on.
Need gas to make stars and just like be who they are, right?
So
yeah, it's just like a tank, like a fuel tank of the galaxy.
The good old middle class, white picket fence, gaseous clouds.
Yeah.
What about dust?
Oh my God, no one cares.
Yeah, no one cares about dust.
No, we care very much.
But basically, so whatever happens in the suburbs affect the cities, right? And so whatever happens in the halos of galaxies like seriously affect the cities. And so, the stuff that's spit out of the galaxies by like supernova or supermassive black holes that are like super powerful things that just like drive things away really fast, right? So they drive stuff out of the galaxies and they build this fuel tank, right? But then at some point, this fuel tank like loses stuff and loses fuel, and the fuel goes back into galaxies, and that makes more stars. So it's just like this whole cycle keeps repeating itself, and basically studying how that, actually happens.
It's so similar how you and Kelly tackled a very similar problem or question in completely different ways.
Yeah,
right?
yeah.
Because you're also doing galaxy evolution.
Right.
You're talking about
we're
gas.
basically looking at the same
theory.
thing. He studies absorption and I study emission.
Yeah,
because there's two different ways you can look.
Pretty much, I think we're going at the same questions. It's just like the biggest difference is that her technique is different from my technique.
Yeah.
Farhan, I'm sorry to cut you off. Do you need to be good at maths to study astronomy? It's all caps, so we know it's either very important or they're 45.
Oh yeah.
I'm not honestly not that good at math. Like
I think it helps.
It helps.
You just need to be like you just need to be good at math within an order of like 2 magnitudes.
Also, I think that being good at math is just like being engaged with it, just practicing a lot. And that's what you need to do in astronomy. Just like be engaged with the math of it, so that you're doing science.
Mm-hmm.
Yeah, that's it.
Yeah. Also, it's like in what context? There's so many branches of math. You should be good at the math that's relevant to your field.
Right. Yeah.
Yeah.
Like you and me, we have to do tensor stuff. We have to be familiar with the group theory. But if someone gives us like, oh, you're good at math, name every
star.
Name every
what
number.
Is Heine-Borel theorem and state it with all the presuppositions that come with it. Heine-Borel theorem. Hell yeah.
Honey Boo Boo theorem. You heard it here first, folks.
Heine Boo Boo theorem said ain't nobody Ain't nobody know that.
Is astronomy the same as astrology? Yes, it is.
No, shut up.
Yes, please don't believe that.
Oh my God.
It's not. It's absolutely not. Astronomy's respectable.
But that is like the most common question I get asked though, whenever I tell people I study astronomy. That's
Oh my
the
God, what
first
sign are you?
Related.
What sign are you? What's your
In what
sign?
way?
Are you
was
plus
that
or
sign?
minus? What's your sign? Are you
Plus
plus or minus? What's your sign?
East Coast or West Coast signature? Yeah. We're gonna keep going back to picking on metrics.
That's a very,
April.
very important question. I think I'm more towards. I think it's like a spectrum. I don't think it's a
God,
binary.
you're such
plus
an Aries.
minus.
You're such an Aries.
So I'm more towards the middle of the spectrum. It's just like no, nothing.
Okay.
Neutral.
Here's a question. I don't
So
even
you're
know what it
Capricorn.
means. So it says, how will
Obviously.
you
No,
explain
I don't know.
how you explain a BPS state black hole that is mass equals charge? Oh, it's like a Kerr black hole, right? Those are the charged ones.
Yeah. I think
I've
I think
never
the Kerr is
heard of
the,
a
you got the
yes.
Kerr charge. I think the
Oh my
Kerr is the charged one. One of them is a spinning one with no charge, and the other one is spinning
Neumann?
with charge.
That must be
Kerr
like,
Neumann is spinning and charged.
So that sounds like a completely theoretical thing because we've never heard of that.
I mean, spinning on what context, right? On a cosmological scale, if it's going a millimeter. I don't know how fast black holes spin. I don't know. By the way, what
And
exactly
which
is
black hole?
Honestly, though,
Yeah, which
I don't
one?
think I do either.
in whose frame?
Yeah. Take
Then
that,
it's
eat it.
Spinning.
What's the spin
Put
of a
some
black
syrup
hole?
on those pancakes and eat them.
Stirrups, like the
The syrup?
What?
No. I said put syrup on
Syrup.
pancakes and eat them.
Like for pancakes.
Put
Well, and
syrup
now I'm
on those
officially
pancakes and ride them.
So yes.
I thought they said stirrups.
No, yeah, I say put some stirrups on those pancakes and ride them like you're heading to the country.
Astronomers are to physics as biologists are to chemistry.
That sounds like a
Same
someone's talking
opinion.
shit.
All right, you know what? This is a safe space. Okay,
Yeah.
everybody love
Yeah,
everybody.
no, come on now. We don't need
We're all
that.
equal.
You'd be banned if I knew how to do that.
Spinning black
No, you
holes.
wouldn't.
No, I don't even think you can boot people in YouTube chat. I tried to do it once.
Yeah, maybe not here. Okay, but in here,
This is PG-13, guys. Come on, keep it clean.
plus or minus.
Plus-
Galaxy
PG-13 plus or minus 5.
form is basically
Wait, where's this
close.
thing?
Dude, I really wish I could.
I know,
stop
like, can
this.
we God,
Yeah, can everyone
so many
stop?
questions.
See, this is
Okay.
everyone would be great if you just let me host, Andrew. We could go to commercial break, but you don't know how to do that. I do.
That's
How do-
right.
yeah,
By the way, Dylan, if you need to go to the use something,
God, where is it?
feel free. We'll,
Dude, I'm in
you know.
quarantine. I've been holding pee for 2 months.
Messy clumps of matter.
Well, no one's making you do that. That is your
Heaven and
choice.
what? God damn it! I just want to read the question.
Okay, so
Did you
I
just say-
feel like
Did you say gosh with a hard?
I'm.
Gosh.
Yeah.
Oh my god.
This is
You
a Christian
too?
channel. We gotta go.
so. I think
Okay.
the question was like, do galaxies form in ordered structure or in messy clumps that just happen to find planets, etc.? So first of all, they don't happen to find planets; they form planets. Can't have planets without galaxies. Pretty much
Boom.
first thing, but like also I think answering the larger question, I think it's I don't think they form an ordered structure. I think it's very obvious that they form it as like so gas clumps is a better answer.
I guess
Gas clumps
it
form
depends on what you
stars.
mean by ordered structure, though, because like
You heard it here first. QFT and Chill with Andrew Dodson.
print is random,
Where we don't talk about QFT, we talk about
but like
astrology.
we're talking about
Astrology.
astrology right now. Shh.
No, I mean astrology is approximately astrology to 2 orders of magnitude, so I think it's okay. Which is
With what?
Which
See,
is
I think you're supposed to-
/ aprox astronomy.
Sorry, I don't mean to cut you off. You're just coming off as stupid. They approximate the approximation. Okay, they approximate the order of magnitude. So 10 within 10 to the 2 is also within 10 to the 3. Okay. Nice
Stop.
guitar.
Just stop listening.
Do you even
to
know
you.
Wonderwall? No, come back.
Me, we gotta do squats. What do you mean?
Nice slides. Did you get those from the slide store?
Sad.
Oh, thank you, dude, my dude.
I'm sorry, Dylan. Farhan, what do you think? I can't see the question anyway. It's already gone.
God, this is hard.
Heck and shoot, dude.
How do you do it?
I don't.
This is my first day.
My first day. This is my first day.
Don't do that.
No, that's like my Canadian accent.
No, don't do that.
I'm feeling good.
Oh, hey, where you been?
I let it all out.
Okay. Well, Farhan, I missed your question. I'm sorry.
Yeah, I don't know.
have no
I
idea
don't know
where
how
it
you guys
went.
are answering any questions, honestly. It's like,
Man, this is fast.
are you guys like streaming how fast these comments are coming up?
This is real time.
This is faster
like,
than a
but can
spinning
people
black
see
hole.
like how
to be
like the
honest.
comments?
They
Oh my
can,
god, you
yeah.
have so many subscribers,
Yeah,
Andrew
'cause they're-
Dawson.
What's up?
What? Oh,
I didn't hear that.
Can't hear you.
Oh.
Beats by Dre.
Do
Hey,
positrons have their
you gotta
own
plug it
electric and
in.
magnetic fields? Yeah, they're the same as electrons. Just actually, no, I shouldn't say that. I was going to say, but with a
Andrew
minus
likes
sign.
Kelly.
They also have what? Opposite parity?
He likes me.
Charge. Parity.
Yo,
Yeah.
you're gay.
Okay.
Sorry.
I think I saw a question.
Okay, this
Which
dude
one?
named Raul needs to stop fucking doing whatever he's putting on. Like that's like the
What?
8th one in a row.
Oh, I think he's trying to what are they, emojis?
Send emojis. Yeah,
Emojis,
Raul. I appreciate it, brother. That's nice of you, but I see it now.
I wish I knew what your emojis were.
Oh, there it goes again.
We'll never know.
Well, if he just sent it, then
Oh, there it goes again.
okay. Well, now you're just being a dick.
Yeah, no,
Come on,
his phone number's there also. So
All right, love you, Andrew Dawson. Star Wars or Star Trek? I never really got into Star Trek, to be
Same.
honest.
Me neither. Yeah, what is that
Same.
about?
He's a very pro Star Wars.
Yeah,
I'd like to check it out.
right. But I don't think that was a big thing. when I
Griffiths
was
or
little.
Sakurai. That one just went by.
Say it again.
It says Griffiths or Sakurai.
Oh, dude, Griffiths loses that battle every time.
Yeah, no,
Right?
I'm with you. I'm with you 100%.
Hold on.
Griffiths
Hold on.
Griffiths will get bodied.
Let me qualify.
Okay.
Griffiths E&M is second to none. Griffiths Quantum is stupid.
Oh, that's
Oh, shots fired. If you were on my show right now, you get DJ air horns like 10 times over.
E&M is great. E&M is
I
incredible.
didn't read the quantum one, but the
Yeah, man.
I actually
Yeah.
like this better, to be
You did?
honest.
He
Yeah.
gets into Brockett notation. He's like, oh, by the way, in the appendix, in the index at the very end, Brockett notation is a thing. It's like,
I think it's actually chapter 4.
it's the same.
But-
That's what I.
But he does it after he introduces wave functions, and I think it's a bit choppy. I agree. It's
But
a
I'm
bit
like-
weird.
I don't know.
At my
mean,
university, it was known as chapter 4. Like you'd say, "Oh, you got a chapter 4." Like it was the thing.
I love Sakurai though.
No, Sakurai's, beauty on a stick, wine with 5
Better
worms.
question, or different question, I should say. Sakurai or Shenkar?
Sakurai wins the battle.
Same.
Both, I think, easy.
Yeah, I agree.
can't keep up. Yeah, this is too fast. I'm already a slow reader, and it's like
That's scoff. Oh, how are heavy elements dispersed from stars? Ooh, that's cool. That's literally what I'm studying right
Define heavy
Carbon
element.
4.
Like, for you guys, is that like helium or something?
No, I think
Uh,
it's heavier than iron, right?
Oh, so 20.
now.
I don't know if we would call it heavier
Okay,
than iron.
so like
I thought it was
astro-
because that's when supernovas start to,
well,
I have iron.
so no,
Sorry,
no,
go
no.
ahead.
Heavy iron is super heavy. That's like super heavy. Heavy is anything heavier than helium.
no,
Oh, well, that's like literally everything but hydrogen and helium.
metals are everything but
Basically.
helium.
Yeah.
Someone in your
Okay.
comment said it really well. It's everything that's processed by stars. So like hydrogen and helium were made when the universe was made at certain
Right.
times.
Okay.
Right.
But
Everything higher than iron, everything heavier than iron was created
It's a
during the
supernova.
supernova.
so maybe that
Thumbs
is-
are fingers,
or
but not all
neutron
fingers
stars.
are
maybe-
thumbs.
Yeah. So neutron star
Whoa,
mergers
right.
and supernovas. So maybe that would be what heavy metals are. I don't know.
Oh, someone just said
Something that can't be
Sakurai is also
fused inside the
trash.
stars.
I value your
Can't be
opinion.
fused inside the stars.
Boot them.
Heavier than
Get them out of here.
Griffiths
I
did
know
nothing
Inside-
wrong.
I can't.
No, I
Griffiths
agree
did-
though.
anything.
No,
Henry.
I actually I do want to come in like slight defense here in Griffith's quantum mechanics, because that was the first book that I learned from, and I don't know, because I actually coming into quantum mechanics, I understood differential equations, and I had taken E&M, and so partial differential equations, separation of variables, all that's great. So I was like, oh, this is kind of neat. But at the end of the day, it didn't really. I was like, okay, what's so different about this than just solving Maxwell's equations with certain boundary conditions? And it didn't become apparent to me until I got to like chapter 3 or 4. I can't remember what it was called. And then it was like, oh, okay, there's an actual, like, we talk about state vectors. This is an actual, like, this quantization isn't just a mathematical trick. It actually is saying something deep about reality.
Pink Floyd?
Oh,
Is it Pink Floyd?
I don't think so.
Yeah, I mean, I have Griffiths, don't get me wrong, and I don't think there's a better alternative for undergrad. I'm just saying, read Griffiths E&M and then go to Jackson. Jackson's notoriously difficult, but
I agree
E&M,
with you. I agree with you there, yeah.
And
there was
one
up here that
Griffiths quantum.
Look, Farhan took a class with Griffiths himself, so let him talk.
Reed? Yeah. Oh, you went with the Reed? Oh, do you know Naomi Gendler? She went to Reed.
Yeah, that's Griffiths' alma mater or whatever. He taught there for like 30 years or whatever. He was still there when I went there, and yeah, we did like a couple of we got a couple of glimpses of the man himself, and one of them was like introphysics, and one of them was like E&M for the book he wrote. Like we were reading his book.
I'm sure he chose that one. Yeah.
Yeah. Honestly, the crazy thing is,
Jackson.
Crazy thing is, he's like super humble. He's like, you can tell that he's someone so like
revered.
Yeah, and everyone around the world knows his name.
God damn it, dude! That sounds like the life. Like, it's like you're just like doing you at a college. You don't have to deal with grad students. You're just like dealing with. Just like, God, that sounds like such a man. Like, I'm gonna like start a farm. Yeah,
definitely. I think he made the best of like his options. Like,
that's so great.
Yeah,
seems like a
super happy guy. His E&M was a fantastic book. I just mean, like, if you do Griffith's Quantum and then you go to Sakurai, you're not as prepared as if you do Griffith's E&M and then you go to Jackson. That's my opinion.
Yeah.
Interesting.
We didn't use
Griffith's. No, I mean, you are right. You are right, because he really abandons the state notation. So I mean.
That's all you use, right?
That's all you need. And
world.
It is beautiful.
You okay?
I remember in undergrad being like, dude, I hate Brockett notation. When is this going to end?
Griffiths dropping E&M.
Brockett? Yeah. Forget about it. It's over.
Let's see. Let's go for some more comments.
That's awesome, though.
Yeah.
Sakurai is good only if you're already good at quantum mechanics. I don't disagree with that statement. Actually,
yeah, no, I agree with that statement. But I mean, like, we weren't forced to choose between Griffiths or Sakurai. We were forced to choose between. Oh, were we? Fuck.
No, I mean, our only option was Griffiths, and just at the time, I was like, "It's great, it's Griffiths." And
I thought you meant like when you asked me a question. I remember you asked me a question, Sakurai or this, this or that,
Shankar.
And then Shankar, and then I thought there was another one, but yeah. Oh, it was Griffiths. It was Griffiths or Sakurai. It was.
And I thought that question was like, you're comparing a graduate level book to an undergrad one.
It's like saying, like, who would you choose in a dunking contest? An NBA player or a high school player?
It's the Carbon 4.
I saw someone saying Tritium Gang. Yeah, all about that H3.
All about that H3, hell yeah! Love me.
So you guys say for first thing that comes to mind to other people when you mention astronomy is the astrology stuff. For me, it's always bomb stuff.
Really, I've never gotten a question like that actually. Oh, because you say the word, because you say the N word, nuclear.
Well,
I literally did not. Okay, we can. I didn't mean that one. I meant
Did you mean nuclear or nuclear?
I meant I meant nuclear.
There's a lot of words in the dictionary.
Noam Chomsky.
How much GR do you use in astrophysics?
7.
Depends on what you do
7.
or that.
How much year? Yeah, it does depend on what. Like that's more of a cosmology thing, I think.
Yeah, if cosmology, then a lot.
Or black hole. I
Or-
mean,
Sure. But if like anything else, then not very much.
Oh
we don't-
wait, Andrew,
wait.
somebody was telling you how to
Yeah.
use slow mode.
I see. Settings gear, which should be next to the fan sharing button above the chat.
thank you, Burger.
So
Wait,
maybe I have to go to YouTube.
Yeah. So I was saying, wait, who said thank you, Burger? You're welcome, by the way. I don't know who said it though. Okay, so I'll take over then. That's fine. This is my podcast. This isn't the first time I've taken over Andrew Dotson's channel.
I didn't
It's
even
all good.
I just left.
Yeah, I know. He just yeeted. He was like, I can't do this with Dylan. He's just no.
Right, where I'm heading out.
Uh,
Ha.
okay, let's see. Jesse Crawford, let's fight. Okay, y'all, come on, keep it
Dylan
down.
is here, man.
Okay, so we got a question of what branch of chemistry? I believe that they're not talking to me. Oh man, PV equals nRT, and that's the tweet. That's what they sent, and that's a verifiable fact, at least in the right domain of. It says okay. Pog. What does POG mean? People keep saying that.
It means player of game. Player of the game.
I don't
Play
think
of
that's
the
what it
game.
means. I
No,
don't think that's what it means.
PogChamp, like PogChamp, like you did the thing that saved the game. That was the play of the game.
Oh, play of the game. I thought you
Yeah.
said player of
Player.
the game.
You can use it
I've not. I
interchangeably.
still haven't.
Okay, here we go. Do you know? He says, do you know that Dirac notation? Man, these are really going fast. You know what Dirac notation is? Disadvantage notation. No, it's not. You're wrong. It's okay to be wrong. Andrew, what's the best stat mech book? I would say Patria, and I think you would agree. All right.
That's a really good book.
Somebody wants to know. Okay, so here's a question, Mr. Captain Frosty. I'm reading it very fast. This is for Dylan. Do you have a whiteboard? Yes, I do, but it's in my office, and I am currently not allowed to penetrate those fortresses. Okay. PogChamp. Oh, man. Okay, now I look like a boomer. Great, because I asked what Pog meant. What the fuck? Great, this is so cool. We get it, guys. Okay. Physics of galaxies. Pog. What the fuck? Oh, I see. You were explaining.
Question.
Very good question.
Yeah.
Can you remind me what the advice was to get the slow?
Oh, that's so.
No,
far
dude,
back.
that is so gone. That is in the ether of the YouTube comment section.
Everyone, we're gonna
It's
take a
not real.
3-hour break and find that one comment that was done.
Yeah. I mean, I'm sure it's Googleable if Farhad or God damn it.
Farhad.
God fucking damn it.
Wait, what about Farhad?
Oh, he said Farhad.
Farhad.
So let's go ahead.
I said Farhat with a hard T.
It's an N.
There's a W. Farhad.
Who knows?
Yeah, I'm just googling. If you don't mind reading through some comments.
Oh
and
yeah,
then I'm
let's
just
do this. Let's do this. Yeah, let's do this. Okay. What do you think about Hassani math book? I don't know who Hassani is. Is it easier to make friends in grad school than undergrad? Kind of, because you're all commiserating together.
Yeah. I agree with that.
Yo, Andrew, are you Hagoromo Chalk Gang? I am. Are you?
What?
Yeah, I have
Yo,
some,
is that
actually.
a Reedy? I
Is
feel
it-
like that's a Reedy.
Is it in the safe? Oh, I thought you were.
Is it in the safe?
I thought you were about to reach into the safe.
I keep 2 things in that safe: chalk and something else.
Andrew, I swear we have the same backpack.
Really? Did you get it on Amazon?
You
Yes.
do have the same backpack. I've told
It's
you.
exactly the same.
Oh, Hagoromo, nice. Yo, I have like a 48 pack. I could send you
Oh
some.
wait,
Yeah, send him like 1 or 2.
look at that.
Nice.
Hold on, it's still on there.
Very nice. Is that the OG or is that the after?
No, it's not.
Yeah,
I
you
see.
wanna hear something? You wanna hear something crazy? Like really crazy?
Yeah. Fuck it.
It's that kids in my undergrad at Reed, like the math department, I guess a year after I left, made like a literal like 5 foot long piece of chalk.
A what?
Because they were obsessed with it.
Oh, I see. They backwards engineered the ingredients.
I guess. I don't know what they did. Like they just made it. It was just this big piece of chalk.
Yeah, guys,
so
I'm sorry. I'm having a hard time finding out how to.
That's not going any slower.
Cracker Cheese
How-
wants to know why I chose particle physics, and that is actually going to be coming in part 2 of my story that I will be putting on my podcast, which you can find at
Right.
Dylan Berger Physics After Hours on YouTube, this very website you're on. So open a tab and please hit that bell. And
Question.
my shit is fucked.
What happened?
I keep knocking my audio out of my interface, and you know,
Oh, you get too excited.
yeah, exactly. I keep squeezing my legs together.
We should put some pizzas in there.
So
At least just put some pizzas in there.
yeah, right now I'm on the YouTube video itself. I'm trying to figure out how to slow down the chat.
Someone repeat your comment.
They said something about enable slow chat, but I just don't see that as an option.
Yeah. Oh, yeah. Just enable snow chat, bro. Oh, what do I think about David Tong's
Yo, just like
QFT?
slow it down. It's
They're
not
all
that hard.
Yeah, I mean, just hit the checkbox, motherfucker. Come on. All right. This video is not getting monetized, Andrew. This video will not get monetized.
There's too many non-Christian words. Will they not monetize it?
I know. We're very sinful
Oh, I
humans.
can put a user in timeout.
Oh,
what does
that's
that
dope.
mean?
We know what that means. If
Just
y'all
in the
are
corner.
acting up, I can put you in. It literally says hide. Nope. It says put user in timeout, and there's an hourglass.
That is.
Okay.
Yeah. Okay. So, but you can't
Oh,
because
add a
nobody's like.
moderator.
Oh yeah, I know. That's what I'm saying. Oh, call up Jens. Call up somebody. But the thing is that won't slow down the chat. But I think you're in the
Oh, you
right
know what?
way. I think you're in the
You know
right
what?
place. You found it. You
I
found the button.
I hit an ellipses and I added a random person is now a moderator.
Oh God. No. Oh.
Oh, manage moderators. That's an easy fix.
Oh, yeah.
Okay.
Hey, we're gonna head out and cook some dinner because we're hungry.
Okay, sounds
Wait,
good.
wait. How are you guys going out? Are you guys not in quarantine, or are you guys just?
Oh no, they're heading out, but still here.
Rolling out to the kitchen.
Oh, I see. I thought you're like, oh, we're going out. We're gonna go party. We're gonna go have a dope time because it's his
We're
birthday.
gonna go to the bar.
And I was
and
like, I'm
everyone
Yeah, definitely going to the bar right now.
stirs. Bye,
right
guys.
on, right on.
See y'all.
Okay,
Thanks
yeah,
for
we're
having
gonna. Wait, they said press Alt F4 to turn on slow mode. I don't see what that could hurt.
Can you do it on yours first to make sure that's not like,
Yeah.
oh, and that displays your email address to everybody?
Yeah, no, I'll do that.
Boy, I guess that you're not sharing your screen or anything, so I guess that wouldn't do anything.
Nothing happened for me.
All right, if that is like the immediate, here's your social security code, your number, then the chat's gonna end. Alt F4. We'll see.
Yeah.
It says leave site. The changes. Oh wait, no, that actually worked.
Oh wait, is it slow now?
Wait, no, it's not.
Oh, okay, let me look it
I
up
think-
for you. So why don't you take over the chat and I look it up for you now, since there's less people in the room. You're freezing, Andrew. Uh-oh. I think it's about to be my show again. Oh, shit. Oh, shit. Is this my podcast? Is he Rip? Is he Rip right now? No. Boomer. We're all boomers. Oh, no. Oh, no. Hey, guys. Okay, so yeah, I guess Alt F4 did that. No. It closed the window, didn't it? Yes, it did. No, he'll be back. Don't worry. He's in here actually, and he can yeah, it's just us and Dylan. Good stuff. I'm just gonna put this back in here. Hey, there's Dr. Phil. How you doing, buddy? Oh, Dr. Phil on this half. All right, he all F forward. Am I the host now, or am I? Yeah, my name is Dylan Berger. Physics After Hours. You can find me on YouTube. Oh wow, 283. Man. Wow, 400 people. Okay, Dylan, put your channel name in the comments. Okay, will do. Oh, wait, they won't let me put it in the comments unless I go to the stream, which is probably not that great. But just search my name or go to Physics After Hours and you'll see my channel there. Oh wow, look at all my subscribers. You guys came through. How awesome. Yeah, Physics After Hours. Go ahead. It turns out I'm not being presented. Hey, it's me and Dr. Phil. How you doing, doctor? Yes, I understand that you're frustrated. You're looking to your right. I do understand this. Can you guys see Dr. Phil, or is that just me? What about physics before hours? Oh, physics before hours. That's the kind of thing that happens, as Abril Degon asked me how I was feeling. I'm feeling wonderful. Yeah. I'm gonna go ahead and sacrifice myself here. And I want to know if Andrew. Andrew, do you want me to cut off my video feed? Just shoot me a text, buddy. Shoot me a text. Let me know. Somebody said engineering is greater than physics, and it's okay. We all have to tell ourselves things, to wake up in the morning. I understand that. Dylan, you're muted. Oh heck, no, that's not true. Okay, I will freeze you. Says Dylan. How do you feel that there are 3 different formulations of quantum mechanics? And I say that there are far more than 3. Shreyag S. Kumar. Heckin ended my video on accident. So Andrew just texted me. He said he heckin ended his video on accident. God bless. But the stream still stands because I'm here. And this is a wonderful thing. I don't know. I can't share a link with him. I want to share a link with you. Andrew, if you're seeing this, Dylan, why don't you look like the guy in your profile picture, Jack Tombert? Well, that's because I got a physics degree. Okay, let's see. Dylan, what do you think about the Wolf from Physics project? I think he kind of paraded deep into an abyss from which he won't return. It's very philosophically unsophisticated. Okay, question from Samuel Alonso. Hey Dylan, what's the dirtiest calculation you've made in StatMech? Oh Lord. I could see you working, Andrew. That's good stuff. The dirtiest? Nothing really. I mean, they're not really that dirty. Dylan, can magnetic monopoles exist in the domain walls of different spontaneously broken symmetries? Yeah, absolutely. I mean, I don't know what spontaneous symmetry breaking has to do with that, but I mean, like monopoles are a thing you can kind of connive in a certain field theory. Dylan, tell Andrew not to Alt F4 next time. Okay, fair enough. Let's see. Keep on going. Andrew Dotson, click the settings button next to the fan button. It gives you a drop down for slow chat. That was the advice. Whew. Man, this is reading real fast. Dylan, what do you think about fluid mechanics? I think it's very difficult and it takes a long time to simulate. Hey, Mr. Nomer. That is not me. That is my alter ego. Dylan, how do you feel about 3 different formulations of quantum mechanics? You asked me that. I swear if I read that again, I'll be very upset. Dylan, can magnetic monopoles exist? I just answered this question. Good Lord. Oh, hell. Is Andrew live? Yes. Dylan, do you believe that the Big Bang Theory has done a service or disservice to the field of physics? Yeah. I mean, it's a perfectly fine theory. I don't know what kind of question that is. Okay, so send them to the ranch. What does that mean? How to prove e to the pi equals pi to the e. That's easy. It's trivial. Just take pi equals e equals 1. Take it on, baby. Are you the new Andrew Guy from Jizzy Nothing? That's a weird name. Seek help, Jizzy Nothing. Okay, field theory is just a... Oh, comments coming in too fast. F's. Haha, Chavez Romero. Tips to study physics. Yes, study hard. Okay, David Bardo. Dylan, how do you feel about 4 different quantum languages? Okay, okay, let me see. Okay, so Andrew's texting me here real quick. So he says, I'm not gonna put no, I don't have the option to add another video source. I mean, just share my screen. There's nothing here. I can try and go offline and then just completely be blank. Let me see. Turn this off. Can I turn this off? So why can't I turn my video off? Probably because I'm the only one left here. Oh, yeah. Let's see. Okay. We can do this. Oh. Oh, well, okay. Well, that was closer because I came off. So let me just turn my video settings off. Let me do this. Different camera. Different mode. I know I'll answer your questions, but I'm also trying to answer Andrew's question because this is his YouTube account. All right. I'm sorry. But I'm not sorry. He's asking me if I have the option to add him, but I don't. So I can't even end the stream. So I don't know what's going on. Okay. Welcome to Physics After Hours. Yeah. I mean, I could unplug my camera, I guess. Okay. Let me see this real quick. Okay, I'm about to. I know F's in the chat for this one, but I'll still be with you auditorially. Let me just do this. She's going to sleep. She's going to sleep. No signal. And I'm gonna go ahead and now take you out of your misery. And oh, hey, I'm on my other webcam now. God bless it. I'm gonna go ahead, take a quick moment of silence. I'll be right back. So many F's in the chat. So many F's in the chat. What you know at it? Baby. What you doing with all them F's in the chat? I don't know. How many F's in the chat? I can't tell. Baby. Can you guys hear me? Dylan, what are you studying? Okay, hold on. Everybody just calm down. Everybody just take a deep breath. It's all gonna be okay. It's all gonna be okay. I can exit out of this. Hold on. Let's see what happens if I do this. No, I don't want to remove that source. That's the only source I have left. Okay. Andrew wants to restart the chat. Let me call him. I'm gonna call Andrew. Okay, hold on. I got an idea. This will be funny. Wait. This will be funny. Say hi to your followers.
Thanks for having me on the show. Dude, this is like a dream come true, to be honest. A lot of people said this would never happen. And we showed you.
Oh, lots of feedback. Sorry.
So I think I'm going to everyone in the chat. I'm going to restart the stream. And no matter what, I'm not going to delete my video this time because now we know. Now we've tested it twice. There's no way to come back if you delete your video on accident.
That's true.
So I'm going to stop and restart the stream. Feel free to click on it again. Please do, actually.
Please do.
You're on this stupid slower chat.
Well, Andrew, they said they can't hear you. Press Alt 4.
Want to know what's funny?
What?
I'll tell you what's funny after I restart the stream.
Yes, please come join us.